Assalamualaikum and good day everyone. Today, me and my group members will be presenting our group project titled Newton's Law in Everyday Transportation. Nowadays, transport are the most important medium for us to transit from one place to another place and is being a part of our everyday life. Whether we travel by car, bus, train or airplane, the movement of these vehicles follows the same scientific rules, and these rules are Newton's law of motion, introduced in 17th century by Isaac Newton. It explains how vehicles move, how they stop, and how they interact with their surroundings.
The behavioral dynamics of this interaction are systematically governed by Newton's three laws of motions, which provide the theoretical framework linking force to kinematic. The first law establishes forces as the critical agent required to disrupt a system inertia. Object will sustain its velocity or state of rest unless acted upon by an unbalanced external force.
Have you ever noticed that when a car suddenly brakes, our body feels like it's being pushed forward? Well, that's actually Newton's first law in action. So basically, Newton's first law, or the law of inertia, it says that an object will keep moving unless an external forces stops it. So, when a car is moving, both the car and passengers are moving together at the same speed. But once the driver presses the brake, the braking system creates friction to slow the car down. So, here's the interesting part. Even though the car slows down, but our body still wants to keep moving forward because of the inertia. And that's why seatbelts are super important in this case. The seatbelts acts as external force that stops us safely and prevents us from being thrown forward. So basically, every time we use a braking system and wearing a seatbelt, we are experiencing Newton's first law in real life. Now you know.
The second law mathematically operationalizes this relationship by the formula F equal to ma, demonstrating that the acceleration of a given mass is directly proportional to the net force applied.
Have you guys ever noticed how at the green light, the small cars zip away while the big heavy trucks take forever to get moving? That's not just the driver being slow, that's Newton's second law in action. Newton's second law states that force equals to m times force equals mass times acceleration, which is F equals to ma. This means an object with more mass takes a lot more force to move at the same speed as something lighter. Think about it, a heavy truck has way more mass than a tiny car. To get that truck to accelerate at the same rate as the car, the engine has kinetic energy provide a massive amount of force. The lighter car accelerates faster than the heavier car when both are subjected to the same force. This is because the lighter car has less mass, making it easier to accelerate. In contrast, the heavier car has greater mass and therefore requires a larger force to achieve the same acceleration. This clearly demonstrates Newton's second law and explains why heavier vehicles need more powerful engines and stronger braking systems.
Finally, the third law highlights the reciprocal nature of mechanics, asserting that forces always occur in matched pairs, where an action force simultaneously triggers an equal and opposite reaction force.
We see cars moving every day, but how do they actually move forward? Well, that's actually because of the exchange of forces between the tires and the ground.
The third law, for every action, there's an equal opposite reaction. As the car's tires spin, they push backwards against the road. That's the action. Simultaneously, the road pushes the car forward with the exact same force. Now that's the reaction.
Now, you might wonder if the forces are equal. Why don't they just cancel out? It's because they act on different bodies. One of the force is on the road and the other is on the car.
Studying this law helps us to understand not only the science behind transportation, but also the importance of safety features like seatbelt,
airbags, braking system, and aerodynamic design. Engineers rely on this principle to improve efficiency, reduce accident, and create new technologies in transportation.